In this lecture, we are going to have an overview on electric vehicle organs and their functions. We will then look into how they all work together to create the most advanced and awesome vehicle on earth. In this figure, you can see the major components of an electric vehicle. The first organ which we are going to look is the charging port. Then we have the high voltage traction battery bank. Then we have an electric motor or the traction motor and a transmission system which are used for propelling the vehicle. And at the last but not the least, there are several power electronic converters that are used for battery charging, for driving the motors, and for regenerative braking. The schematic diagram which you can see explains the architecture of components and how they are connected with each other in the electric vehicle. To know about the organs of an electric vehicle, let us follow the power flow directions and take a look at an electric vehicle to identify the major components. The first component we see is the charging port with charging connector and cable. The charging port collectively with the connector and the cable allows the electric vehicle to connect to the external power supply so that it can charge the traction battery bank. The charging port is known as to be the vehicle inlet. If the vehicle is charged with the power from the domestic power grid, it requires an onboard charger, which is exactly a power electronic converter. A power converter is the assembly of a high power semiconductor devices which works as a high speed switches. Different switching stages modify the input voltage and current by using the capacitive and inductive elements. The result is an output voltage and current which, when compared to the input, it has a different magnitude and waveform. The onboard charger converts the arriving AC power provided by the charge port to DC power for charging the traction battery bank. The onboard charger resembles your mobile charger but can handle quite nicely the high voltages and powers. The next most important organ is the high voltage traction battery bank, which is the heart of an electric vehicle. Generally, the battery bank is situated at the bottom of the vehicle, but it may vary manufacturer to manufacturer. The major role of the battery bank is to stock the electrical energy for the propulsion of the vehicle. The battery bank has a battery management system that keeps records and regulates the battery charging characteristics such as voltages, currents, temperatures, and state of charge. The energy content of an electric vehicle or a battery is generally expressed in kilowatt hours. Currently, the electric vehicle have battery sizes in the range of 10 to 100 kilowatt hours and even more. Now focus on the battery technologies that have been functional to electric vehicles. First is the lead acid type of batteries. The usage of the lead acid batteries in EVs are restricted due to low voltage or the low energy densities, sensitivity to temperature, and life cycle. Next is nickel metal hydride type batteries. These are widely used for traction purposes and are improved for high energy content. And the most common are the lithium based batteries. Now the lithium batteries are diversified by the type of active substances into the lithium ion liquid electrolyte and a lithium ion polymer electrolyte batteries. The lithium ion type is preferable for EV applications, mainly driven by its high energy density capacity or the capability. The table which you can see shows how a 20 kilowatt hour lithium ion battery has a much lower weight than other players. When you drive an electric vehicle, the power flows from the battery to the motor and to the auxiliary vehicle accessories like luminous systems and audio systems. To adjust the power between these devices, it is compulsory to use a power electronic converters. In an electric vehicle, a DC to DC converter steps up the DC voltage of the traction battery bank to a higher DC voltage required to propel the vehicle. A secondary DC to DC converter is also used to step down the voltage of the traction battery bank to charge the lower voltage auxiliary battery. The next important organ is the motor drive. The motor drive regulates the speed, the torque, and the rotational directional of the drive motor. Depending on the type of motor, the motor drives is a DC to AC inverter or a DC to DC converter that is used to regulate the power flow between the battery bank and the motor drive. The motor drive is a bidirectional converter compared to the power converters, which we can see earlier as are proficient of transporting power to the motor for propulsion and even remove out the motor for regenerative braking. Now we will look into another organ, that is the electric motor, which together with the batteries are of two vital parts in an electric vehicle. The electric motor is a reason for converting the electrical energy to the mechanical energy for driving the vehicle through the transmission. Generally, the single gear transmission with differential is used as opposed to variable gears found in the combustion engine vehicles. That is why electric vehicles are automatic gear vehicles by default. This is due to the exclusive nature of the electric motor to deliver near to full torque at all speeds. Further, the same electric motor can be used both as a motor during driving and as a generator during regenerative braking. Four types of electric machines have been used in both PHEVs or the plug-in hybrid electric vehicles and battery electric vehicles till date. They are induction motor, permanent magnet motor, switched reluctance motor, and a brushed DC motor. It can largely be concluded that induction motors and permanent magnet motors are the most popular motors when considering the various constraints such as control, efficiency, power density, reliability, and cost. Finally, the last two key organs of an electric vehicles are the auxiliary batteries and power electronic converter. The auxiliary battery delivers the electricity to start the vehicle before the traction battery bank is engaged and also powers the vehicle auxiliary accessories. The auxiliary battery is usually 12 volts for current vehicles but may be amplified to 48 volts for future vehicles. On the other hand, the power electronic converter no doubt controls the different power converters and hence indirectly the operation of the batteries, motors and the vehicle. It uses the driver accelerator input and brake pedal input to control the power flow and select the operating mode between the driving and regenerative braking. It commands the on-board charger and the battery charging simultaneously with the battery management system. Now that we know the different organs of an electric vehicle, then let's look at how does an electric vehicle work based on the electrical power flow. This image shows you the typical electric layout of the components in an electric vehicle as seen before. Let us examine one by one. The power is delivered from the AC grid to charge the battery via the onboard AC to DC rectifier and DC to DC battery converter. When the vehicle is in the driving mode, the power delivered by the battery goes through the battery DC to DC converter to the high voltage DC bus. Then the DC to AC inverter of the motor drive guides the power to the motor. The motor then renovates the electrical energy to the mechanical energy and it is guided to the wheel via the transmission. Simultaneously, a DC to DC unidirectional power converter steps down the voltage from the 300 volt high voltage DC bus to charge the auxiliary battery of 12 volts, which is responsible to power the vehicle accessories. Hence, to recap, the battery or the traction battery bank, the electric motor and the power electronics are the vital organs which may play a major role in the operation of an electric vehicle. Since power is traded between these components electrically using the cables, it delivers the boundless flexibility in the design of the vehicle. This flexibility is not possible with the vehicles with a mechanical drivetrain due to huge size and the weight of the mechanical components. That's all for this lecture. To get such intriguing methodology of EVs and its component, do subscribe our YouTube channel, follow us on Facebook and Instagram. Also check out our most affordable electric vehicle technology course. Links are below at the description box. Thank you very much.